All right, hi everybody. Welcome back to this channel. Thank you very much for joining once again. We are continuing with counting, and we're just gonna look at the creation of this question. Uh, it's about word arrangement, and we are using counting principle to determine how many different words we can form using the letters of the word. In this case, is independent, right? Okay, so we've done a counting session and quite a lot of counting principle session. You can go to our playlist. You'll find a lot of videos on counting, also focusing on past papers for your Department of Education and all that. And you can just also we have a session on Kevin Smith textbook, the whole textbook where we did a whole of all the examples in that textbook on counting principle, right? So if you're struggling, there's a lot of sessions that you can check out on the playlist. I'm just gonna drop it also on the description or on the tab on top there so that you can just refer to it as well. All right. Okay. So today we are moving. We are doing this question, words arrangement, and it's saying find the number of arrangements of the letters of the word independent. Independence. In how many of these arrangements? The first one is saying, do the words start with P? We want to count how many different words can we form if the word is going to start with P, right? So in the letters of the word, in the word independent, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 letters, right? We have a total of what? Of 12 letters, right? 12 letters. Where from those letters, we have N, which is repeating how many times? 3 times, right? So N is repeating 3 times. And we have D, which is repeating how many times? 2 times. And we have E, 1, 2, 3, 4. E, which is repeating what? 4 times. Do we have another repeating letter? Let's check. I think we don't have, right? Let me just confirm. We have N, 1, 2, 3, it's fine. Then we have D, 1, 2, it's fine. Then we have the E, 1, 2, 3, 4. Then we're left with C, E, I. Okay, yeah, there's no more repeating letter, right? Okay, so we can start. How many words can we form that start with P? So if we're gonna start with P in the first position, there's only one way to do that, right? Because it's fixed. That is put P, right? That is the only way. Then the rest of the letters such as I, N, D, E, N, D, E, N, C, E can be arranged in anyhow, right? So we're just gonna count how many of those because we know from permutation if we have n items, different items, then we can arrange in n factorial way, right? But if there's some repeating items such as r and or like that rp, we can divide by the factorial of those what repeating ones to cancel out their effect, right? So that we don't count repeating letters as different, right? Okay, so if we're starting with P, that's one way there. Then the rest of the letters, we're just going to count them, how many are left. Obviously, from 12, we'll be left with 11 of them, right? So this can be arranged in what? 1 times, 1 is for P, times inside the remaining one, 11 factorial, because you have 11 letters divided by the factorial of the repeating letters, right? Because we have to cancel out the effect of repeating so that you don't count the same letter twice, right? Okay, so obviously from this, we have n that is repeating 3 times. We're going to divide by 3 factorial times. We have e repeating, d repeating 2 times, 2 factorial times we have e repeating 4 times divided by 4 factorial, right? So you have 11 factorial over 3 factorial times 2 factorial times 4 factorial, right? We can just use our calculator to get this. 11 factorial divided by 3 factorial times 2 factorial times 4 factorial. Okay, so the answer will be 138,600 words that can be formed that start with what? With P. Okay, that's quite a lot. 138,000 different words that we can form. Okay, so that's it for the first one. Let's go to number 2. Roman figure 2. So number 2 says, how many of these arrangements do all the vowels occur together? Okay, we want to know if all the vowels must always be together, how many different words can we form? Okay, so if all the vowels are together, what are your vowels? Your vowels is I, E, which is how many of them? 4 of them. 1, 2, 3, 4. Okay. So I think those are the only vowels in the letter in the word independence. So these must be what? Together. I'm just gonna put them there. Then the rest of the letters such as N, D, and D, and C. Let's check if they are forming 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, and also P. 12. Okay, these ones they can be arranged in anyhow, but these ones here, I'm just putting them on this box here on this unit because they must be together. Okay, so how many different words can we form? So basically, if they say something must be together, you consider them as one unit, as one thing, because they must always be together. Then it will be like we are counting. It's an item on its own, right? So we'll say 1, 2, 3, 4, 5, 6, 7, 8, right? We have 8 different items, right? So this one says together, we count them as one item, and the rest of the letters that can be seated in anyhow, we count them as also different items, right? So we have 1, 2, 3, 4, 5, 6, 7, 8 items, right? So this can be arranged in what? 8 factorial ways, right? But from these items, we do recognize that here, there are some of the repeating letters like N, it's repeating 3 times. You're going to divide by what? 3 factorial. And also you notice D, it's repeating 2 times. Going to divide by what? 2 factorial, right? But again, guys, don't forget, inside those ones that must be together inside here, although they must be together, they can be arranged in different ways. We have to also multiply with the number of ways that they can be arranged inside that unit, right? Because this is not the only arrangement we can start with E, then I, E, E. You see, there are many different arrangements that can be made also inside. So we're going to count the items inside. 1, 2, 3, 4, 5. So inside they can be arranged in what? 5 factorial over the repeating letters E are repeating how many? 4 times over 4 factorial. Okay, so the total answer now will be 8 factorial times 5 factorial divided by 3 factorial times 2 factorial times what? 4 factorial. Okay, so these ones in red, it's there inside the unit, the number of arrangement inside the unit, but this one, it's all the items all together here, right? Where this one, we're considering it as one item, and we count 1, 2, 3, 4, 5, 6, 7, 8, 8 factorial, and the repeating ones we divide. Then inside the different arrangement that can be made, we do that. Okay, so we can use a calculator to get the answer of that. So it's 8 factorial times 5 factorial divided by 3 factorial times 2 factorial times 4 factorial, right? So the total number of ways of words that can be formed, it's 16,800 words. Okay, that's quite a lot as well. So 16,800 different words that can be formed. Okay, so that is it for number 2. Let's go to number 3. Let me just make this bold a bit. So number 3, saying how many of these arrangements are possible if all the vowels never occur together. Okay, this is a bit of a trick question. It's quite interesting. And if you check, there's one session that we did that is called Counting Principle, the Not Rule, right? The Not Rule. On the channel, if you check on the videos, you'll see it. And it's basically solving a reverse way, right? Because you can't actually get the answer of the ones that do not occur together like straightforward, right? Rather, how do we tackle this question? So basically what we do is we go and calculate the total number of different arrangements, right? Total number of possible arrangement. Then from that total possible arrangement, we subtract the arrangements when the vowels are what? Are together. So that our answer, we can get the answer of the arrangement when the vowels are not together, right? Obviously, you'll get the answer of when they are not together. So basically, it's a reverse. You calculate the total arrangements, possible arrangement, the words, minus when they are together, all the arrangements when they are together. So the answer you get will give you the answer of arrangement when the vowels are not together. So that's basically how you calculate, and we call it the not rule, right? So basically, to answer this question, to get the total number of words that can be formed or arrangement that can be formed when the vowels are not together, we are going to say arrangements when vowels are not together. Hence, we call it the not rule because they are saying not together. Is equals to, we are going to the total possible arrangement. And from this, we subtract total arrangement when vowels are together. So if we go to the total possible arrangement and we subtract total arrangement when vowels are together, we get the total arrangement when vowels are not together. Okay, total possible arrangement of this word independent. It has a total of 12 letters, where N is repeating 3 times, D 2 times, and E 4 times, right? So total possible arrangement, we have 12 letters. They can be arranged in what? 12 factorial ways divided by the repeating letters, 3 factorial for N, 2 for D, times 2 factorial for D, and 4 factorial for E. This gives you the total possible arrangement of the letters of the word independence, right? Minus the total arrangement when the vowels are together. Fortunately, we have calculated it in Roman figure 2 because they said calculate when the vowels are together, right? We already know when the vowels are together, we have a total of how many? 16,800 arrangements when the vowels are together. We calculated it in the previous question, right? So we can just go on our calculator. We get this 12 factorial over 3 factorial times 2 factorial times 4 factorial. Then we get, this is a lot, 1,663,200. 1,663,200 minus 16,800 minus 16,800. So it's going to be 164, 6,400. Okay, different arrangements that are possible when the vowels are not together. Okay, so it's like 1,646,400 arrangements. Okay, that's pretty much a lot. Okay, let's go to the last question. Roman figure 4. It says, how many of these arrangements are possible if the word must begin with an I and end with a P? Okay, so if the word must begin with an I, there's only one way, that is to put I there, and it must also end with what? With P. There's one way at the end there. That is put P. Okay, so then the rest of the letters N, D, E, 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 N, P, P is already out, N, C, N. The rest of those ones can be arranged in anyhow, right? If it begins with I, ends with P, if we are beginning with I, there's one way there. That is put I. If we're ending with P, one way, put P. Then the rest of the words, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. They have to be, if we subtract 2, they have to be 10 here. Which one did I leave? I, it's out. P is out. Let me see. Did I leave another D? Yes. So there must be D. Okay. So how many are possible? So we have 1 times 1. So these ones are when you start with I, end with P. But inside there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they can be arranged in what? 10 factorial ways divided by the repeating letters. D is repeating 2 times, 2 factorial. And N is repeating 3 times, 3 factorial. And E is repeating 4 times, 4 factorial. Okay, so that will give us the total number of words that can be formed, given that we start with I and end with P. So we can just go on our calculator, say 10 factorial divided by 2 factorial times 3 factorial times 4 factorial. Okay, so it will be only 12,600 words, 12,600 different ways that can be formed. Okay, so those are the number of arrangements that are possible. Okay, guys, this marks the end of our session. I hope you find it helpful. Guys, with letter arrangement, it's not a bit tricky. I mean, it's maybe the tricky one will be the one where you have to use the not rule, but you can really conceptualize it. It will be quite different, guys, if they give you the same word. Let me just show you. If they give you the same word, independent, and they say how many different, what is the total possible number of arrangement, given that the repeating letters are treated as different. So in other words, there's no repeating letters because you are treating these repeating letters as different. In other words, this can be N1, this can be N2, this can be E1, E2, E3, E4. This can be D1, D2. The repeating letters treated as different. How many total number of arrangements are possible? In this case, everything is different because you are treating repeating letters as different. So it will just be how many items are there, how many letters are there. There are 12 letters. They can just be arranged in what? 12 factorial ways. We don't have to divide by the repeating because in this case, you are treating repeating letters as what? As different. But in this question, they said nothing about repeating letters. So we treat repeating letters as repeating. In other words, we have to divide by the factorials of the repeating letters. Okay, I hope you find this helpful. Yeah, that's all for me. See you soon on the next session. Bye.